Okay, let's start with importance of water to life. Notes. So properties of our water. In water, as you can see here, there is one oxygen atom, and there is hydrogen atoms, and there are more electronegative in oxygen atoms. Remember, covalent bond is when oxygen shares electrons with each of the hydrogen atoms. Electrons spend more time with oxygen than hydrogen. So, the oxygen is partially negative charge, while hydrogen is partially positive charge. So in this case, that is why these opposite attracts, and that's why they are the hydrogen bond. This is what you call it. It allows liquids. Things that have change dissolvable in water, but things that don't have charge that cannot dissolve in water. Looking at this would have allowed molecules to start collecting, philosophical biolayers. Molecules where one end is hydrophilic, meaning attracted to water molecules, and other end is hydrophobic, meaning not attracted to water molecules. This would have allowed molecules to start collecting membrane, forming special spherical membranes, which could be containers for early cellular life. And some vocabulary here is density is a master unit, volume of substance, a Fourier molecule is uncharged, neutral molecule having an asymmetric internal distribution of charge leading to plus or minus reagent. Second, high heat capacity. Amount of energy needed to raise 1 gram of water by 1 degree Celsius. Many life forms can operate with certain temperatures. 3. High heat evaporation. How much energy does it take for water to go from liquid form to gas form? 4. Cohesion and adhesion. It can adhere to other things. Adhere means sticks fast to. Cohesion is when molecules are attracted to other water molecules. This forms no water drops. This allows nutrients from roots of the tree to travel to the top of the tree by water. Ice is less dense than liquid water, allowing it to flow. And when waters interact, they form hydrogen bonds. Elements and atoms. Objects have different properties. Elements are substances that are pure substances that have different properties at certain temperatures and heat in certain ways. Example, carbon, lead, and gold. Smaller equals atom. Example, average human hair has 1 million carbon atoms in width. And it's made up of even more fundamental particles. They are defined by the arrangement of these fundamental particles, and the change in the number of these equals the change in properties of element or elements. Constitutions of an atom. 1. Proton is positive. It defines element. The number on top is the number of protons equals the atomic number. 2. Electron is a negative charge. 3. Neutron. So this is the neutron with just the number of protons or number altogether, and number of protons cannot change. These blue are the neutrons, orange is proton, and these are the electrons. The electrons are kind of far away. The blue mean the neutrons and the protons are kind of counted together. Protons and electrons have opposite charges, attracting to one another. Electrons are attracted to nucleus and have high velocity. Electrons can interact with other electrons and can be taken by other atoms. Moving on to more notes on matter, elements, and atoms. Some atoms can lose or gain electrons or form bonds with each other. Simple interactions between atoms make life possible, and even living things can form bonds with each other. Matter. It refers to anything that occupies space and has mass, all made up of elements, and it cannot be broken down to other substances. Element is designated by chemical symbol, single capital letter, or 2 letters, or it can be abbreviation in Latin. 4 elements common to all living organisms: O, oxygen; C, carbon; H hydrogen, and N nitrogen, and make up 96% of the human body. Non-living world elements are found in different proportions. Some elements living on the earth are rare. All elements and chemical reactions obey the same chemical or physical laws, regardless if they are part of the living or non-living world. An atom is the smallest unit of the matter, retaining all chemical properties of an element. An atom has two regions: the tiny atomic nucleus, which is the center of the atomic and atom and protons. There's positively charged particles called protons, and neutral uncharged particles called neutrons. The second larger is the cloud of electrons. They're negatively charged particles that orbit around the nucleus. There is attraction between the positive protons and the negative electrons that hold the atoms together. Subatomic particles are protons, electrons, and neutrons. Hydrogen is an exception because there are no electrons in hydrogen. To the number of protons in the nucleus determine the element of the atom. The number of electrons surrounding the nucleus determines the reactions the atom undergoes. So this is kind of like a graph of it. As you can see here, it's the neutrons here, the nucleus, the protons, positive charge, and the electrons. The atom of helium has 2 protons. Protons and neutrons don't have the same charge, but have approximately the same mass, about 1.67 times 10 negative 24 grams. Scientists use Dalton or automatic mass unit AMU instead of grams. 1 neutron/proton equals 1 AMU. Electrons are smaller than protons is 1 out of 1,800 atoms. Out of AMU. So they don't contribute much to the element's overall atomic mass, but they greatly affect the atom's charge because each electron has a negative charge equal to the number charge of protons. Uncharged neutral atoms is the number of electrons orbiting nucleus is equal to the number of protons inside the nucleus. Plus and positive and negative charges cancel out the atom with no net charge. Protons, neutrons, and electrons are very small, and most of the volume of the atom, which is greater than 90%, is empty space. This is on a new video. Atom is the uncuttable. It is not the smallest form of matter. It is neutrons, electrons, and protons, which is the fundamental particles. The nucleus is the nucleus, and there are neutrons and protons in it. The electrons are orbiting around the nucleus, but this is not the truth. It cannot be described this way. So as you can see here, I drew a graph. So this is the protons and the neutrons. As you can see, there are 2 of each. It is inside the nucleus, right now the center of the atoms. And the haze right here is the lighter color is the 2 electrons. Generally, helium doesn't gain or lose. Also, this is a picture of the helium. Electrons, because it is highly stable atom being noble gas. You cannot know the momentum or location of at any given point in time, but you can know its probability of distribution of where it is likely to be. Orbital equals a function of where the electron is. And that is it for all the notes. Thank you guys so much for watching. I'll make sure to post this on the website. I hope you guys like this video. Press the subscribe button and love and comment below. Thank you guys for watching.